All right, we are doing part 2 of P4, rational exponents and radicals. So this part 2 video is going to cover the rational exponents portion. Okay, so take notes, P4, part 2, and we are dealing with rational, again, rational keyword ratio, so like fraction. So fraction exponents. Okay, so let's just recall what it means when we have a fraction exponent. So if you have this, some base to some exponent, and that exponent is a fraction, then that fraction exponent means that you are taking a radical, a root. And so this number here in the denominator represents the root that you are taking of this base. So this here is the root, the radical, and this here is the exponent as you understand it to be. Okay, so that n is your nth root. Okay, and the m is your exponent as you know it. Okay, so you can look at it like this, the way I just wrote it. So it looks like you're taking a to the m, and then you're taking the radical of that. That's one way to look at it. Or you could do the exponent after you take the radical. So you could do the radical first here, and then raise it to the exponent. Either one is fine. Okay, one might work better than the other at times. Okay, all right. And for example, maybe you have this 3 to the 3 halves. Okay, so again, this bottom number tells you what kind of radical you're taking. So this tells me I'm taking the square root. Okay, so I am taking the square root of 3 cubed. Okay, and so this is like saying you are taking the square root of 27. Okay, and this is, I can break this up. I don't even have to do the square, right? When I have this radical without an index here, it's understood to be the square root. So you don't have to write the square root. You don't have to write the number 2 there. Okay, I can break this up. And the square root of 9 is 3. Square root of 3 is some decimal number. Okay. All right, so go ahead and try these. See if you can simplify these. Again, that bottom number in the denominator represents the radical that you're going to be using. Okay, so try these 3 problems. Number 1, 4 to the 1/2. Number 2, 8 to the 2/3. And number 3 here, 125 to the negative 1/3. Okay. Okay, go ahead and hit the pause button and come back when you're done, and we'll see if you did them correctly. You can also hit the pause button and then do one problem, come back, hit the pause button, do the second problem, come back. That way you can check your answers as you go, or just do all 3. Okay. All right, so this means square root of 4 to the first power. So that's just square root of 4, which is 2. Okay. This is cube root of 8 to the second power. So this one here, cube root of 64. Or you could do cube root of 8 and then raise it to the second power. Okay, either way is fine. Cube root of 64 is 4. And then this one, cube root of 125 to the negative 1 power. Okay, so here, so what I'll do here is for this one up here, I went ahead and did the exponent first, then the radical. So what I'm going to do here is I'm going to do the radical first and then the exponent. Either way is fine. So cube root of 125. Cube root of 125 is 5. And now I can do to the negative 1 power, which is 1 over 5. Okay? Okay, and then we also have the lots of exponents here, and they still hold true for exponents that are fractions. So here are some examples uh, uh, with the laws of exponents. So remember, if you multiply like bases, you can add the exponents. If you divide like bases, you can subtract. Okay? All right, so for example here, if I have a to the 1/3, a to the 7/3, then I can add the exponents 1/3 plus 7/3, and I get a to the 8 over 3. Okay? Same thing with something like this, a little more complex. If you have a to the 2/5, a to the 7/5, and a to the 3/5 down below. This one's not too crazy because at least they all have common denominators. Okay, so I can add the ones above. Okay, so I can add 2/5 and 7/5, so I get 9/5. And then I have this here, so now I can subtract the exponents. So I get a to the 6/5. Okay. And let's take a look at this one here. If I have 2a cubed, b to the 4th, to the 3/2. So I still apply the laws of exponents here. So this will be 2 to the 3/2. And then a to the, remember you multiply. Okay, so you're multiplying the exponents. And this is like over 1. This is like over 1. You multiply numerator with numerator, denominator with denominator. So that's going to be 9/2 for the a. And the b is going to end up with 12/2. And then if you can simplify these, that would be great. Okay, so here, this one turns out to be square root of 2 cubed. And we'll deal with that later. And this is a to the 9/2. And this is b to the 12 divided by 2 is 6. All right, so here, I'm not sure how WebAssign will accept your answers. Oh, you know what? I just thought of something. Okay. All right, so here we have cube root, not cube root, square root of 2 cubed. So that's square root of 8. A to the 9/2, b to the 6. And maybe they accept this on WebAssign, but you're not submitting your homework for WebAssign, so you're just doing it on paper. I would be fine with that. You can also break that down and get 2 square root 2, a to the 9/2, b to the 6. Okay? All right. And let's take a look at this one, a little more complex. 2x to the 3/4 all over y to the 1/3. So this here, you don't have like denominators. And then you're going to be multiplying that with y to the 4th, x to the negative 1/2. Okay. All right. So over here, I'm going to go ahead and deal with this exponent first. So everybody here gets their exponents multiplied. So this is going to give me 2 cubed. This is going to give me 9/4. And this one is going to give me 3/3. 3/3 is the same as 1, so I'm just going to leave it as 1. And then I have this here. And then this has a negative exponent, x to the negative 1/2, so I'm going to move that up. All right. And using my properties again, here I'm multiplying x and x like bases, so I can go ahead and add my exponents here. Okay, so that's going to give me 9/4 plus, I'm going to rewrite this 1/2 as 2/4. That way I have common denominators. And then here I'm going to get 4 minus 1 is 3. So I get 8x to the 11/4 y cubed. Okay. All right. And let's go ahead and take a look at writing radicals as rational exponents. So we're going the other direction now. Okay. So writing radicals as rational exponents. Okay. All right. So, for example, here, suppose that I have 1 over cube root x to the 4th. So here, this is the same as saying 1 over, and this is going to give me an exponent. So remember, the top number is like the exponent as you know it, which is a 4. And then the bottom number is the index of the radical, which is a 3. Okay. And then I can take this one step further and rewrite this with a negative exponent like that. Okay. And let's take a look at this one. 2 square root of x times 3 cube root of x. Okay. So rewriting these using rational exponents, that's square root x. So that's x to the 1/2. And then this is x to the 1/3. And here I would need to add my exponents, but I need common denominator. So common denominator 6. So this is going to be 3 over 6. And this is going to be 2 over 6. And now that the denominators are like denominators, I can go ahead and add those fractions. So I get 2. Oh, actually, so we get 6 x to the 5 over 6. Okay. All right. And let's take a look at this. Square root of x, and then a square root of x here. Okay. All right. So let's go ahead and take care of the inside. That's like x times x to the 1/2. So I'm going to go ahead and add these. So I need common denominators. So I'm going to write that one as 2 over 2. And now I have square root of x to the 3/2. Okay. And that becomes x to the 3/2 to the 1/2, because 1/2 is the square root. Okay. And I can multiply these, and I get x to the, remember, multiply the numerator with numerator. So 3 times 1 is 3, and 2 times 2 is 4. That's only when you're multiplying exponents, fractions. Okay. All right, so that's how you can work with these by rewriting the radicals. Okay, this last part we're going to do here deals with rationalizing denominators, and then we'll be done. Rationalizing denominators. Okay, so we'll do 3 examples here of rationalizing the denominators. So let's first take a look. So first of all, what this means here, rationalizing denominators. So rational, right? Rational. That's a number that is a rational number, right? Ratio can be written as a fraction of 2 integers. So if I have like square root of 2, that's not a rational number. Square root of 2 is irrational. However, if I say square root of 4, which equals 2, this one is rational. Okay, so this one is rational, this one is irrational. Okay, so what we're doing here when we rationalize the denominator is we're taking a denominator that's irrational and we're turning it into a rational number. Okay? Okay, so let's have a look. So suppose that I have this number here, 2 over square root 3. So clearly the denominator, square root 3, is irrational. Okay, so what we want to do is turn it into a rational number, like 5 or 7 or 9 or something like that, right? So we're trying to get rid of that radical. Okay, so what we do here is, since we're dealing with square root, we want to have a perfect square over here. So 3 is not a perfect square. However, if I multiply it, so let me go ahead and use blue. So if I multiply this by the square root of 3, then I end up with square root of 9, right? Which is a rational number. So I'm going to go ahead and multiply by 1, which is in the form of square root 3 over square root 3. Okay, and then what happens is that now in the numerator I get to square root 3, but in the denominator I get square root of 9. And square root of 9 is actually 3. And there you go, 3. That's a rational number. Okay, so that's what rationalizing the denominator means. Turning your denominator, your irrational denominator, into something that is rational. Okay, don't you wish we could do that with people? Take irrational people and then rationalize them. Okay. Anyway. All right. So let's take a look at this number here. 1 over cube root of 5. So we're dealing with the cube root. And so 5 is not a perfect cube, but we do want a perfect cube. So what I'm going to do here is I am going to multiply. Here, let me use my blue again. So I'm going to go ahead and multiply by the cube root of, so if I multiply by the cube root of 5, I'm going to end up with the cube root of 25. 25 is still not a perfect cube. So I need to multiply by cube root of 25. That way 5 times 25 is 125, which is a perfect cube. Okay? All right, so I get cube root of 25 on the top, and down below I get cube root of 125. And 125 is a perfect cube, so I get cube root of 25 in the numerator, and the cube root of 125 is actually 5. So we went from irrational cube root of 5 to rational number 5. Okay, see if you can do this one, this last example. 7th root of 1 over a squared. Okay, so figure out square seventh root of 1. Any root of 1 is just going to be 1. Okay. And then seventh root of a squared. So figure out what you need to multiply by to get this to be a rational number. Okay. So you have a squared, but you need a perfect seventh power. Okay. All right. Hit the pause button. Okay. So here, in order for this to be a perfect seventh, is if I have a to the fifth power, right? Because 5 and 2 is 7 more. Okay, so I'll have a total of 7. So I'm going to multiply the numerator and the denominator by the seventh root of a5. Okay, and by doing that, that will give me seventh root a5 on top, and then down below that will give me seventh root of a to the seventh. Okay, and so here this will remain, but down below I end up with just a. Okay, no more radical. Okay, all right, so that is it for P4. Again, the optional homework assignment is in the book, in the electronic version of the book, not on your homework assignment list on Cengage. So you'll need to go to the ebook and go to section P4, which is on page 29. And you can try out 19 through 89 odd. Again, no need to do all of it, but definitely try a few from each section to make sure that you can do all of those different types of problems. And then just focus on doing the full set of each section that you feel like you're struggling with. All right. I will see you next time.